Hey, welcome back to my channel. My name is Jay Bailey, and today we have a pretty simple challenge. This time it's from the website HackTheBox. If you want to follow along, I have the binary, the password, the tools that I've used, all that stuff is in the description below. Um, this was a pretty simple challenge, but I did learn some pretty cool things about binaries and debugging symbols, and I look forward to sharing that with you guys. Stay tuned. Alrighty, so this challenge comes with two different binaries. We have don't know what I am, and we have get me. And so just like in the first video, we're going to create a notes.txt file just so we can keep track of anything interesting that we find about these two binaries. And we're going to say don't know what I am and get me. And I'm going to put some space in between there just so they have some space. And the first thing we're going to do is, just like in the first video, run file on both of these binaries. And so right away, my eyes are kind of drawn to this here, the fact that the interpreter is empty. And so what that tells me is that this binary actually can't be ran, even though it says it's an elf executable, 64 bits, all that good stuff. If we were to try to run this, and I'll show you, we're going to get an error. And that's because this binary was stripped of any executable parts that would allow us to actually run this program. And if we look here, we see that the SHA hashes are exactly the same. And so that tells me that these two binaries were possibly one and they were split up into two. And we also see here that this one has debug symbols and it wasn't stripped, whereas this binary was stripped, the get me one. So what I'm thinking is that the get me is the executable. This is the executable. And this one is actually just debug symbols, if I can spell this, for get me. All right, so, and this is where I'm going to deviate a little bit from the challenge, and I'm going to show you how you can do this. And so if you already know how to do this, how to create different, like a debug symbol, binary, and executable, stay tuned. But if not, you can skip it. And also, if you're not interested, you can also skip this too. But I thought this was cool, and so I want to share that with you guys. So I have this simple C program, and all it does is it adds two numbers and it subtracts two numbers and it prints it out to the screen. And I just added these two functions in there just so I can have more symbols in there. I mean, you don't really need it. You can just put plus, or minus, but I just wanted to do that. And so I'm gonna compile it with the -ggdb flag, and that's just gonna add debug symbols to this binary. You could just very well just not have this dash. You can just put -g. Now I think that should be sufficient, but I believe this adds more debugging information, so I like to just put as much as I want in there, as much as I can. And I'm gonna just compile it. So now when I run file on test, you see that we have an interpreter. Then we have which debug info here, and we see that it's not stripped, so good, right? And so we can run this, and let's just say 5 and 2, and everything looks correct there. All right, that's good. So I want to create a debug symbols binary. So what I'm going to do is I can use this object copy command. I'm going to say only keep debug. And I'm going to say test, and I want the output to be called test_debug. Right, so now if I were to run file on both test and test debug, we see that it looks pretty similar to what we had over in our target binaries, right? So we have the interpreter is empty, and we also have the hash files are the same, and we see that the debug symbols are here, and we see that it's not stripped, but we also see that there's still debug symbols in our actual executable. So we want to get rid of that. So that's simple. You can just run the strip command and tell it to strip debug, and then you can say also strip sorry, I had to spell that out slowly because I always mess that up. And so now if I run test_debug, you see that it's now been stripped, and I have the debug information here. And so, but now I can still run test, right? And it still works the same. And if I try to run the debug one, we get an error. So we're almost replicated what this guy's done in our target binary, this DSYM, these two DSYM binaries, get me and don't know what I am. There's one more thing we have to do to sort of make this equivalent is the fact that if I were to try to run GDB on test, you see that there's no debugging symbols found in this binary. And you'll say, well, duh, you just stripped them. But then, you know, there is debug symbols, right? They live in this binary, test debug. Well, GDB doesn't know that yet. So we have to create a link between test debug and test. And we can test. You know what I was trying to do. And so we can do that with object copy again. And we can say add GNU debug link. Gotta spell it right. And we're gonna say test debug and test. So now when we actually run GDB here, we'll see that they've read the debug symbols from this binary. And so now we can do things. If I want to add a breakpoint to this, I can say break at main, and we see that it actually works. And I probably should have showed that it won't work earlier, but it wouldn't have worked. It would have said it's undefined. All right, so now that's awesome, right? So now we can debug it with debug symbols in there because there's a link between test and test debug. However, if you were to try to do some static analysis, like load this in Ghidra, like what we're going to do for our don't know what I am and get me binaries, as of right now, and to my knowledge, there's no way to tell Ghidra to look for the debug symbols in this binary, but actually load this binary. If you know how to do that, please throw that in the comments. I would love to know, but there's no way to do that to my knowledge. But there's another way we can do it. We can unstrip the test binary and put the actual executable information in the debug binary, and we can run this command called eu unstrip. And if you don't have it, you run sudo apt install, I think it's elfutils, and hit dash yes. I already have it installed, so it's probably going to say nothing to do. Oh, if I could type my password in right. Yes, I already have it installed, but if you didn't have it installed, that's how you install it. And you run eu unstrip, and we're going to say test debug. So now let's look what happens. And now test debug has an interpreter. You see now we can actually execute this binary. So if we run test debug, you'll see now they're exactly the same. And so now what we could do is analyze this binary in Ghidra, and we'll have all the debugging symbols, and it'll be very easy to analyze. So taking what we know, what we just learned, let's apply that here. So like I said, we can't do that, right? We can't run this binary. So we can unstrip get me and put it in don't know what I am. So now we see that, you know, these two are exactly the same. And so let's run don't know what I am, and nothing happens. Let's see, maybe it wants input. No. Let's see, it wants words. No. All right. So let's try to actually run the original binary. Nope. Maybe you want words or letters, words, something, anything. No. All right. So it looks like it's not doing anything, but we don't fully understand it yet. So let's go ahead and open this up in Ghidra. All right, so we're going to create a new project here. And this is again a non-share project. And let's see here. Default up one, that's where we want to put it. And we're going to, what is this? DSYM is the name of it. And we're going to import the don't know what I am binary because that's the one that has the debug symbols. So we want to load that one in here. And we see everything looks good there. elf80, x86, all that good stuff. So hit OK. You see him chomping on the bits. And yep, that's good. Hit OK. And to begin our analysis, drag it to the dragon. All right. Do I want to analyze it? Of course I do. Ghidra, come on. And so we're still going to use the default options here. Hit analyze. And you see it's doing its thing down there, and we see it's done. Cool beans. So now let's go to the main function. So we're going to just type main, and you see that it filters here and go there, and let's see. It's actually doing nothing here. You see, like, so we see function prologue, right? And then we see it pops REP and then it just returns. So this was what we saw was correct. It is not accepting input. It's not printing anything out. It was just exiting. So let's see. So there has to be something that we have to do here. So I'm going to go ahead. I don't think I did this earlier. I should do this earlier, but I'm going to run the nm command. I'm going to do this. And we see that there's another function called notme. So let's just go back into Ghidra and look for notme. And let's see what this function is doing. And so this is where we see the benefits of having debug symbols, right? So we see that this is an array that's being loaded with these values in here. So let's scroll down some more and we see that here it's printing out this message. And we see this here is like a counter, right? So you set I equal to 0, and then let's see, it jumps here, and so this is going to be a loop, and we see that's going to compare I to hex 15. So I'm going to go back in here, and I'm going to say while I is less than, what is it, hex 15. Let's see, what is it going to do here? So it loads. So this here is going to be our first array. Well, sorry, I kind of told myself again, but this here is our array that we know of, right? So this RBP minus hex 60 is this AR array, and this here is how they're actually doing indexing. So right now, so this will get the first index of this array. That's how in assembly that's how it looks. Kind of gross, but that's just how it is. So this is so we have AR sub I, right? So that gets loaded into EAX, and then you see it gets XORed with hex 29. So essentially it gets, XORed with 29A. Sorry, 29A. I don't know why I always say 29. All right. So then EAX gets assigned to EDX. So now EDX, I'm gonna get rid of this, but I just want to keep track holds. I'm just gonna say AR sub I 29A, essentially. And then we say load EDX into this array. So this is a separate array, and we see that's still the same index. So I'm just gonna create a new array and say, I'll just say AR2 sub I equals AR sub I 29A. All right, so now I'm just gonna get rid of that. We don't need it anymore. And actually we don't need this anymore either. So all of this here equates to that pretty much, right? So like that, yeah, so assembly is pretty gross, but one line in C is a couple lines in assembly. But it's all right. That's nature of the beast. And so then we see, remember that in the last video, how it sets up the call to the printf function. So we see that EAX, which holds AR2 sub I, which will be loaded into the ESI register. And then we had this here, I'm guessing it's gonna be the format specifier. So if I double click on this, it'll bring me here. And so it tells you what values are in this address here. And so we see that's %X. So, all right, that makes sense. So if I hit the back button, then it's taken back, which is pretty awesome. And we see printf, so so essentially what that is, looks like is printf %X and AR2 sub I, just like that. And then we add 1. All right, where is it at? There. Come on. What did I do? There we go. Sorry about that. I plus equals 1. And that looks like about it. And it looks like it prints out on something else. Let's see, what is this? I think that's new line. And that's all the functions. So after the loop, Okay, so it'll just printf new line like that, and that's pretty much it. So this is what the notme function is doing. So I'll just say notme function. So this pretty much all it's doing. Well, as you see, I actually first it assigned some values to this first array, and I won't write all the values, but that's what it did. So I'll just say some values in here, and it's going to assign it to this value after it XORs it, and it's going to print it out in hexadecimal format. That's what the %x is. And so what we can do two things. I can copy all of these values here, you know, from 0 to hex 21, or 0 to 21, sorry, and I can just do the computation myself and XOR it and see what I get, or I can have the program do it for me. Oh, but wait, Josh, I thought the program isn't doing anything. The function never called anywhere. That's true, but I'll show you how we can get around that with GDB. So I'm gonna load the don't know what I am into GDB, and so I'm using the Jeff extensions. As you can see here, it says Jeff in there. If you didn't install it, it's just gonna say GDB, but I think in parentheses. I haven't used it in a while, but it's just say GDB. You don't need the Jeff extensions for this, but I just like to have it because it's useful for when we get into like exploit development. It'll be easy to develop our exploits. But for right now, you don't necessarily need it. But if you want to follow along exactly, you can install it. It's very, very simple, and the link for all that should be in the description below. So what I'm going to do is I'm going to create a breakpoint, and I'm going to tell it to break at the main function. And then all I'm going to do now is hit run. And so this is a lot. I'm not going to go over all this right now, but this up here we have the register values. Well, like all of these here are register values. And here we have the stack. And down here we have actual executable code. And so this is why I like having Jeff. I think PETA, which is another similar tool that has this kind of layout, but I've always used Jeff, so I stick with Jeff. And so I like to have, you know, the registers up here and the code and all that good stuff. And so you see here, this arrow here points to the next instruction is going to be executed. And so if you don't know much about how programs are run, this register here, RIP, points to the next instruction that the computer is going to execute. And so you see here, this value here equals to this value here. So they're exactly the same. And so what we can do here, I'm going to tell the program to disassemble, and you can this DISAS is like a short for disassemble. I'm going to say disassemble the notme function, because that's the function that we want to call. So I'll disassemble it, and I'll do that because I want to get the very first address of this function, which is right here. So I'm going to copy that. And like I said, I know that RIP is going to be the next instruction that's going to execute. And so what I can do is, what's awesome in GDB is you can set register values. I'm going to say set RIP equals to this here. And now when I go to info registers, get information on the registers, we should see, there it is, RIP equals to this value here. And you see there it points to not me. And then if I were to disassemble not me again, you'll see that it has a little arrow, meaning that that's what's going to execute. And so I can't just step through this one by one, or what will make more sense is just hit continue, type continue, or you can just type C and hit enter. And we get this value here. So this is at the hexadecimal value that gets printed out as a result of that process that we kind of went over here. So this here, so it gets XORed and it gets printed out. So this is the hexadecimal value here. It gets printed out. So we almost got it. So now I'm just gonna hit copy this, and I'm gonna exit out of Jeff or GDB, and I'm gonna use a tool called Decodify. And so this is a pretty slick tool. If you give it some, you know, either hexadecimal value, or you can give it like other hash values as well, and it'll print out, it'll decode it for you. And it even detects what it is too. It isn't perfect, but it works pretty good. And the link for that is also in the description. So we hit that, and we get this message here. So this is decoded from hex. So this is obviously what we want, because we know that it's a hex value. So if you've ever done a HackTheBox reverse engineering challenge, they all have the format of HTB, and then it'll be some flag, and then it ends it like that in curly brace quotes. So this almost looks like it's the actual flag here. So I'm gonna just copy this, and I'm gonna put that in there. And so since we know that the first three values should be HTB, let's see if there's like a relationship between these values. Like if there's like a simple, like if there's just like a simple, you know, add subtraction type of thing. So what I'm going to do is I'm going to go to Google, and I already have the ASCII table pulled up. And so I'm going to look at U, and the value for that is 85, since U was the first letter, and H is 72. And so 85 minus 72 is 13. So the difference between these two is 13. So that's good. All right. So now let's go from G to T. So let's see. G is 71 and T is 84. 84 minus 71, 13. All right. So it looks like it's going to be just like a 13 offsets will be the key. So let's last one, let's do just for completeness, O to B. So O is 79 and B is 66. So 79 minus 56, 13. So it's safe to say that the key is 13. So if we were to try to decrypt this and use 13 as the key, we should get it. And I'm only going to do the letters. And I'm not going to mess with the actual numbers here. I'm only just going to choose to just do the letters. So let's go ahead and try and create a simple Python program. What is it? Decrypt.py. That's spelled out right? Yep. All right. So let's take our encrypted flag, and do I still have it pasted? Yep. And we're gonna do that. All right. So full disclosure, I'm not the best programmer. So if this is not, I guess, best practice, you know, please have mercy on me. Like I said, I'm not the best programmer, but anyways, it'll get the job done. So we're gonna call this function decrypt, and we're gonna give it the flag, and we're gonna give it a key, and let's see, we're gonna create a decrypted flag. We're gonna set that to nothing, and we're gonna say, let's see, for x and flag, we're going to say if x dot is alpha, and I'm also going to say if it is upper, so I'm going to have different, you know, there's going to be different values for the uppercase and lowercase. We're going to do this flag plus equals chr ord x and plus the key, and then we're going to subtract 65, then we're going to mod 26, then we're going to add 65 again. And so I'm doing this just, you know, just to keep things in the actual alphabetical ASCII codes. So this is kind of what has to be done there. And then elif x is alpha and x is lower, dec flag, pretty much the exact same thing, but just we're going to, it's going to be 97. And it's 97 mod 26 plus 97. And so I'm getting 65 and 97 because that's, so 65 is the first letter in the alphabet, 97 which is A, and same thing for 97, which is lowercase a. And lastly, I want to say else just dec flag plus equals x, and so that'll just give me the actual the number. And then I'm just going to say print dec flag, and let's see, if main equals to main, and say key equals 13, and then I'm going to say decrypt inc flag with the key. And that should be all that we need. So let's go ahead and test this out, and hopefully I didn't make any mistakes. And of course I did. Y'all gotta tell me. Come on, man. You gotta let me know. All right, come on. Let's see. Did I make any other mistakes? I don't think so. Let's see. All right, and there we go. And that's it. And so there's our flag. HTB, you really got me. And yes, we did. All right, guys. So quick recap. We're able to solve this challenge by first unstripping the getMe binary and putting the executable parts in the don't know what I am binary. We then analyzed this in Ghidra, and we saw that there is a function called notme, but this function is actually never called in the main program or the main function. We're able to call this function by using GDB. We first set a breakpoint in the main function, and then we ran the program. Then we set the RIP register to be the address of the notme function, and then we just simply told it to continue execution. And we saw that this binary or this value here is decoded, so we used the codify tool to decode this this value. Then we saw that this here it appears to be encrypted with some weak encryption. Then we created this decrypt script in Python that decrypts the string, and we got our flag. So that's pretty much it. Hey, so like I said, pretty simple challenge, right? Not too difficult. If you like this video and you learned some new things, give me a like. I really appreciate that. If you have any questions that maybe I didn't answer or just something just went over your head, go ahead and leave that in the comment section below. Just like I said in the first video, this is a safe space. No questions are too simple. Believe me, like I said, I've had my fair share of dumb questions, so don't be embarrassed about anything. If you like this type of content, you want to see more, don't forget to subscribe and hit the bell icon so you're notified when new videos go live. See you guys in the next one. Peace out.